My name is Wasim Muftah Ramadan Shankada. I study computer engineering. That's our first homework in machine learning. The goal of this project is to apply linear regression to two datasets using gradient descent to predict outcomes based on various inputs. The first dataset involves predicting the profit of restaurant based on the population of the city, while the second dataset involves predicting house price based on multiple factors like the size of the house and the number of bedrooms. Linear regression is a machine learning algorithm used to predict continuous outcomes based on input features. It involves finding the best fitting line or hyperplan that minimizes the difference between the actual and predicted values. In this code, we will use batch gradient descent, which iteratively updates the parameters of the linear regression model to minimize the error between the predicted and actual values. We come to our code. First part of code, we import the numpy as MP. Numpy is the fundamental package for working with matrix in Python. Import matplot library .pyplot as plt is the famous library to plot graphs in the Python. The second part of our code, we load the dataset from file. Loading the data, the first step in the code to load the dataset from a file. We have two datasets, one for predicting profits based on population and another of predicting house price based on multiple futures. We use the NumPy library to load the data in arrays. For both datasets, we separate the futures, the input such as population or house size, from the target variable. The output such as profit or price. The futures are used to make predictions, while the target variable presents the actual outcomes. Future normalize, we come the third part, normalize future. Future normalization, when working with the multiple future, it is often necessary to normalize the data. This process adjusts the scale of the input futures to make sure they all contribute equal to the model. For example, in the second dataset, house prices, one future might be in the range of 1,000 house size, while another could be in the range of 1 to 10 number of bedrooms. Normalizing the future ensures that the gradient descent algorithm work efficiently, as it prevents certain futures from dominating the learning process due to their large values. This is achieved by scaling the futures to have a mean of 0 and standard deviation of 1. The step is only applied to the second dataset since it has multiple futures, while the first dataset only has one future. We come to calculation cost for linear regression. This is cost function. The next key concept in the code is the cost function. This function measures how well our model is doing by calculating the difference between the actual and predicted values. The cost function is essentially any error measure. The goal of gradient descent is to minimize the cost function, making the predictions as close to the actual values as possible. In a simple linear regression, the model predicts a value based on weighted sum of the input's futures, and the cost function calculates how far off the model's predictions are from the true values. A lower cost means the model is doing a better job at making predictions. Gradient function. Compute gradients. This is our function. The gradient function calculates the derivative of the cost function with respect to each parameter in the model. In simpler terms, the gradient function helps us understand the direction and magnitude of the changes we need to make to our model's parameters to improve the predictions. The gradients are computed for both the weight, which determines the importance of each futures, and the base, which shifts the prediction line up or down. We come to perform gradient descent. Gradient descent algorithm. The gradient descent algorithm